Hello and welcome to the video. What we're going to be looking at today is finishing off the angles topic we've been working on. And we're going to be looking at something called F and Z angles. Now they do have proper technical names and they are corresponding angles, and they are your ones that we will call F angles, and you have your alternate angles and they are the ones we'll call Z. And the reason we call them F and Z will become quite obvious. It's all to do with the shape of them. And so, corresponding angles is when we've got a setup that looks like this, where we've got two parallel lines like this, and it looks like an F. And then for alternate ones, it's where we've got two parallel lines like this, and it looks like a Z. And the rule is that your angles here inside the corresponding angle, they are the same. So the angles inside the F there are the same as each other. And then in your Z ones, the angles inside the Z, so inside the little pointy bits of the Z, they are also the same. And that's how these work. So that means if this was 100 degrees, this would have to be 100 degrees. If this was 30 degrees, this would need to be 30 degrees. But it's really important that it's not just your standard F and Z like that. So obviously, if we see a shape drawn like this, that's obviously an F, and this one is obviously a Z, and we'll recognise that and we'll know the angles are the same. Note that these have to be parallel lines, but we could have something that was flipped round in other directions. Okay, this would still count as an F angle, and these ones would be the same inside the F. If we had it going the other way for the Z, this would still count as a Z angle, and these ones inside would be the same. We could even have it sideways like this. As long as our lines are parallel, well, that's still an F, isn't it? Because look, we've still got our F shape like this. And because we've still got our F shape, this in here is the same. If we had a Z shape that looked like this, it's on its side, but there is still this Z shape to it. And so that means the angles inside would be the same. So it doesn't matter about the orientation of the F or the Z, as long as you can see that F or that Z shape in them, it allows you to work out those angles because they match. So let's look at some examples of this. And what I'm going to do, I'm just going to draw at the top your standard F and your standard Z, so we know what shape we're looking for in our examples, because we will have to do some where we're using multiple of the angle rules together to find out missing angles. So I'm just going to pause for a second, and then I'm going to draw some questions down for you. So what I've done here is I've put a couple of examples down that's going to use the F and Z rules and some other rules we've learned about finding missing angles. So first, let's look at this one here. So we're told straight away, this is 110, and then I want to find each of the angles I've marked with a dot. And so, what I'd be doing here straight away is, well, I'd be saying, I've got an F shape, haven't I? It's backwards, but I've got an F shape here. And because I've got that F shape, that means my angles here inside the F match. So if this is 110, then this one here, that has to be 110 as well. Now, we're using another rule. Can you see that along here, we've got a straight line, haven't we? And along here, we've got a straight line. Well, how many degrees are there in a straight line? Well, remember from the last video, it's 180. So if there's 180 in this whole straight line, and this bit's 110, then this bit here, on this side, that has to be 70 degrees. And the same for this one here. And there we go. We filled in all the missing angles. Now let's look at this one. So the angle that's been marked that we want to find out is this one here with a dot. And so we're going to have to see what rules we can use. So straight away, I see that even though it's sort of flipped on its side, I've got a Z shape here. So this angle inside here is going to be the same as this angle here. And so let's work out this one inside there. And again, look, we've got a straight line here. And so for part of my straight line, I've got 140. And so what does the other part of my straight line have to be? Well, it has to be 40, doesn't it, in there? Because along my straight line, it has to add up to 180. So then if that one is 40, remember I've got my Z, that means this one in here, that also must be 40 degrees because they have to match. And then finally, let's look at this one here. The angles that are marked that we need to find out is this one and this one. So we're looking for shapes and rules we can immediately fill in. So I can see here that I've got a straight line, and I know part of it here is 60. And so this whole three of them have to add up to 180. But I don't know these other two yet. I'm going to have to work out one of these before I can work out the other one. But look, if we look at this, I've got a Z again, haven't I? Here, I've got a Z shape coming down. And so if this is 50 inside the Z, then this one up here, this has to be 50 as well. So that means this here is 50. And then that lets us work out that one missing one, because the three have to add up to 180. So 50 adds 60 is 110. So that means it must be 70 left over to fill in that one. So there we go. That's pretty much all our angle rules used and learnt about. And so this F and Z one, the corresponding and the alternate, was the final part. And the bit you need to remember is it only works if you've got parallel lines like this. And so then it's the angles inside the F that match and the angles inside the points of the Z that match. And you can put that together with the other angle rules we've learnt to figure out a load of different missing angles in shapes. So hopefully that was all understandable. If not, you know how to get in touch. Thanks for watching.